Yeah, hi Karthik. Is my screen visible?
Yeah, yes.
Okay, fine. So let's continue with the KNN. So in our last session, so we have started understanding the basics, right? So we have seen the KNN and it's a very simple algorithm as we have seen, right? And we have also seen the um, yeah. So we have also seen different things like how to like what is K in KNN and then
Yeah,
what are the simplicity of the KNN, how simple it
yes.
is. There is no learning at all. But
Yeah,
there are few problems like space problem,
time
because you have to
complexity
save
problem. Yeah.
the whole data set, etc. Few
Hmm.
pros and cons. And what happens if the K is low? What happens if the K is high?
Yeah,
What is overfitting, underfitting when you will face, and how to find out K. Okay.
yeah.
And mainly like how we are getting K, from where we are getting K and from where we
Hmm.
are getting
Hmm.
NN. Okay.
Hmm. Hmm.
And also so it should not be the as of generally we will not take the values of K to be even
Even
or
numbers.
the multiples of the number of labels,
Yeah,
correct? So
yeah.
those things we have seen. Okay, the basic of
Fold.
it. Yeah.
Yeah.
After that then we understood since the K and NN are depending on test data set and training data set, right?
Hmm.
So directly we cannot divide the data into training and test data set. So then we might be doing some injustice. So
Correct.
that's why we understood there is one concept called as cross validation. Okay.
Yeah.
And what is the use of that is it will divide the data into like K parts,
Hmm.
and then it will give the chance of each and every part to become test data set
Train and train. Yeah.
once.
Test and train. Yeah.
Okay. So, but here one important point is any part will become any part will become as test data
Hmm.
set only once,
Yeah.
but it
Correct.
can become training more number of times.
Yeah.
For example, here if you see, this is a one second. Yeah. So this is the training data test data set. So 1 and 2
Hmm.
are train, 3 is test.
Yeah.
So 3 is becoming only one time test. Here 1
Yeah.
is becoming test, 2 is test. But if you see,
Correct.
1 is becoming train here and here. Okay,
Yeah.
2 is becoming train here and here. Okay. So training it can become, but testing we will pass only once, because only
Once.
once we want to test it.
Test. Yeah.
Okay, why
And
we
also
want
we want more data to be trained.
correct, correct. Okay, fine. So that we have seen. So we'll continue from this point. So today's class will be mostly practical class. We'll see the code. I'll show you two things. One is like basic KNN code. We will see like just
Hmm.
dividing into training part and testing part and seeing the accuracy is one thing.
Mm-hmm.
Second thing, then we will see why this is not working, and we will see the cross validation example.
Oh.
Okay. So cross validation, just to give a quick recap. So instead I was saying if you were using three-fold cross validation, so that means it will create three
Three
models,
models will. Yeah.
correct? And then the input will be test input will be passed to each of these
Three
models.
models.
Each of this model will
To
give
check
you an
the
output,
accuracy.
and based upon that, we'll get the final output.
Correct.
Okay.
Yeah.
Fine. So these things we'll also see today in practical. So this will be very interesting, and you will get a good practical knowledge also. Okay.
Yeah.
So let's start with basic KNN. Okay. So first, let's take this example of Iris dataset.
Yeah.
Okay. So you know Iris dataset, right? So it's having four features
Yeah.
and three classes:
Yeah.
sepal length, petal width, and setosa, versicolor, virginicard output
Virgin.
classes.
Yeah.
Okay. So the problem statement is given a set of these four values,
Mm-hmm.
you need to predict which one of these three classes is the
Yeah.
problem statement. Clear?
Hmm.
Right. So now this is a dataset. So as we can see, we are having four columns.
Yeah.
Okay. And if these are the feature names, and if you see the target value, so this is a target.
Hmm.
Okay. So here on we are only 0, 1. That means we are okay. We are seeing only zeros. Okay. But if you we are, because we are printing only top five. Okay. But if you are having if you see the whole data set, we will have
Ones and zeros.
1 and
Two.
2.
Two as well. Yeah.
Yeah, because Setosa,
Three.
Virginica,
Three classes.
three classes. Okay. Fine. So after that, I'm just using the flower name. Okay. So I'm just mapping wherever zero is there. I'm putting it as Setosa, and one will be versicolor and two will be
Mm-hmm.
Virginica, like that.
Hmm.
Fine. So then this is just plotting between different features. So sepal length and sepal width. Okay.
Okay.
This is a plotting, and we have seen different plottings like petal length and petal width, etc. This we have seen. But now the main thing is here. So just like any other model, so we are going to divide the data into train and test. Okay. So now once you divide it into train and test, we got this. Okay, this is our X train, X test. Fine. So next we are, yeah. So if you are not following, if you have any doubts, you can stop me, Karthik. Okay, I'm
Mm-hmm.
going through the code. So now from SQL, this is how you will import the KNN model.
Yeah.
Okay,
Okay.
from SQL.neighbors,
Mm.
import KNeighbors classifier, and here KNeighbors classifier. So here we have imported, and here we are creating an object. Okay,
Yeah.
this object we are passing the
Okay.
neighbors
Equal to
hyperparameter.
10. Mm-hmm. Yeah.
Okay, so here we are passing it, but if you don't pass it, it will by default take some value. What value is
Yeah.
it? We can check the documentation. So
The
over here,
default value.
if you go to SQL and KNN,
5,
okay.
I guess. Yeah.
So here it is saying, yeah, neighbors initial, it should be integer value, okay, and default there should be 5. Default it will take 5.
Mm.
For the default value, you can give any value, okay. So I'm
Yeah.
giving 10, but I don't know like what is the best value. So that,
Correct.
so but yesterday I was telling you we will loop through a range of values, and for
Yeah.
k we will find out, we'll train different models using cross validation. Like that we will do from, let's say, 3 to 30 or 5 to 20, some range, and
Mm.
then we'll calculate the accuracy, and then we will get the best k, which is
Best.
equal to maximum accuracy.
Okay.
Then we will train the model using that k.
Yeah.
Okay, fine. That also we are going to see in the next example. Okay, but this is
Yeah.
just a basic example which will give you the basic idea. So this is how it is simple. So just give k n equal to 10. Okay, so that means it is considering 10 neighbors.
Yeah.
Okay, for any new data set you pass, it will consider nearest 10 data sets.
Yeah.
Okay, and by default there will there will also be what's called, the distance will be Euclidean. Okay, for example, if you see the
Mm-hmm.
uh,
Directed distance.
yeah, so distance it will be uh,
Min
yeah,
default.
distance is Minkowski, which results in the standard Euclidean distance when p equal to 2.
Oh, okay. Then
Okay.
indirectly, yeah.
Yeah,
First
so
one
that
will be.
means yesterday I was showing you, right?
Correct.
Minkowski.
Minuscule k, I mean, p equal to 1 and p equal to 2.
Yeah, so when p equal to 2, it will give you the Euclidean,
Yeah.
right? So here what is happening is the distance is by default Minkowski.
Yeah.
Okay. But Minkowski will take parameter of p.
Yeah.
Now, if it is p equal to 1, it will be Manhattan. If it is 2, it will be Euclidean.
Indirectly,
Correct. So
Euclidean.
p is that default value is 2. That
Okay.
means indirectly we are using Euclidean distance as default.
Hmm.
Okay. If you want to use some other distance, you can give 1.
Okay.
Okay. So by default, it is using Euclidean. Okay. Now that is fine. And then once you do this knn.fit train, so model is fit, and then you can pass the test data set to get the accuracy. Okay.
Hmm.
And after that, when you pass any set of 4 values, okay, based upon that, it is giving you the answer. Okay.
Hmm.
So it is saying 0. That means this is a Setosa.
Okay.
Okay, this the output. See, you are
Yeah.
following the code, I guess. Okay. So when I run this, I pass 4 values. Why 4 values? Because the model is trained on 4 input features, separate length, separate width, right? So that's why
Correct.
while prediction also you need to pass 4. So now
Hmm.
the model is saying the output class is 0. That means 0
Hmm.
is referring to Setosa.
Hmm.
Okay, clear?
Yeah.
So now when you change this neighbors, right? So there might be some changes. Okay, so for example, I'm giving 5. So now I'm training. So accuracy I got 1. Okay, here if you see accuracy got changed to 1.
Yeah.
Okay, so like that, if you change to, let's say, 15. So okay, fine.
Hmm.
So it is again changing. For example, if I give some other value, say 5.8 and 2.0 and 2.5 and let's say 1.3, I don't know, some random values. So it is saying it
It's,
is class 1, which is versic.
yeah. Yeah. Hmm.
Okay, fine. So now we got the model. This is how simple
Yeah.
to train any model. Okay, just
True.
import and just create an object, fit the model, get the score,
Yeah.
and do the predictions. That's it. 1, 2, 3, 4, 5. 5 steps. Any model. If you want
Correct.
SVM, replace this by import the SVM. If you want logistic, import by logistic. Okay.
Yeah.
But on top of this, then there will be some other additional work to find out which hyperparameter is the best hyperparameter. Okay.
Yeah.
So that we will see. So now we got the model. Then we got the accuracy also. And after that, then we have something called as confusion matrix, right? Classification matrix. So same concepts will apply here. So we are importing the confusion matrix and we are passing the test data set, okay, everything. And here it is saying, yeah, because you are having three classes, so obviously the confusion matrix will be 3 by 3.
Correct.
Right? Setosa, Virginica, versicolor like this. Setosa, Virginica, versicolor like that. Okay. And this diagonal will be the true positive,
True positive.
positive
Yeah.
value. Okay. And all these will be error values.
Yes.
Okay.
False.
So false values, right? So if you see, there are almost correct predictions that are happening. Only one error I can see. Okay. Fine. And after that, you can plot this also. So this is called heat map. Okay.
Yeah.
So I think I have shown you.
Yeah.
So
Seaborn.
yeah. So truth and prediction. So here, as you can see, everything is fine. And only here you see, actually the truth is 1, but it has predicted as 2. Okay. This is a count. This is a count.
Yeah.
So one row, whose truth value is 1, that means Virginica, is predicted as 2, which is Versic. Okay. Apart from that,
Correct.
everything is 0.
Actually, it should be that one, but it is predicted as 2. Yeah.
Actually, it should be 1. So if it is 1, it should be predicted as 1. Okay. So this should come here because the actual truth value is 1. So prediction should also be 1. So this should become 13. But unfortunately, it went here. That's
false.
Why.
Yeah.
Okay. Fine. So it's a small data set. So that's how. And then you can also have classification reports. So for 0, 1 class, 2 class, what is the pressure, recall, FM. So okay. Simple.
Yeah.
Any doubts in this simple code?
No.
Fine. So now, but this simple code, but the major thing is we randomly assumed that k equal to 10 or 15, whatever thing.
Correct.
For example, see, this is the values, right? So now if I change to some k equal to maybe 7, so some values might change. Okay. So the predictions will change, this will change, and there are some changes that will happen. Okay. But I don't know what will be the best k. And also, first of all, dividing like this directly train test split is also not a good choice. Okay. So that's why we will see the implementation of cross validation. Okay. Which is very interesting. So now if you see the cross validation, so which is used for like parameter tuning, model selection, feature selection, etc. The basic agenda is that because we are having a drawback of train test split. Okay. So then we are using the k-fold cross validation.
Yeah.
Fine. So using that, we will see what are the advantages, etc. So same using the iris dataset only. Okay. So we are just loading the iris datasets, and here if you see, these are my x values. Okay. And these are my y values, all zeros, ones, and twos. Fine. Now, when you initially, I'm just like we did just now. So I took some random train with 5. Okay. And I got the accuracy 97. Okay.
Yeah.
Fine. So, but the question is, if we created bunch of train and test splits, calculate testing accuracy for each and average the results together, then that will be called as a cross validation.
Cross validation. Yeah.
So in cross validation, we have seen this, like split the data into k equal parts. Each part is called as one fold.
Correct.
So that's why it's called k-fold cross validation. Okay. So use one fold as test data set and remaining all other folds as training data set. Calculate the testing accuracy and repeat this. And finally take the average testing accuracy of complete for the overall accuracy.
Yeah.
Okay. So now what we are going to do is, this is very interesting, but the essence of it, this is, even though like we need to create like 5 models and find out 5 accuracies and give the average, but everything is going to happen in just one step. Okay. That is very, very
got it.
implementation. There is only one model you need to import, and the job will be done for you. Okay. But before that, so just a basic example, like what is happening in the k fold is, for example, let's say you have 25 values. Okay. So what it is doing 25 values, so k
it is search for from k equal to 0 to 25 iterations.
No, this is not that k. Okay. Forget about that. I'm saying basically the idea of k-fold means, if you, for example, if you give it 100 data points, and you say I want to perform 10-fold cross validation, then it will divide this 100 data points into 10 parts, and each part it will put as a test data set, and remaining 9 parts training data set.
Okay. Yeah.
right? The same
Yeah.
concept.
Yeah.
If it is 5 parts, then 4 parts will be used for training and 1 part for testing.
35. Yeah. Yeah.
But it will make sure every data point will fall into test data set only once.
Correct. Correct.
Correct?
Only
same
once.
thing yeah. So same thing I'm showing here. For example, just a 25 numbers you take and
Mm-hmm.
consider each number as one data point. So
Okay.
simple code. Okay. So what it is doing is when you are passing, see the
K-fold.
way how you import the K-fold is again simple. From SQL model selection, import K-fold.
K-fold. Okay.
Into this K-fold, I'm saying I want 5 splits. Okay. And I'm passing it a range of 25. Range of 25 means like 25 values I'm passing.
So 25 values, it's
From 0 to
divided into
24.
5 parts.
Okay. Yeah. So this 0 to 24 values like 0, 1, 2, like till 24 values are divided into 5 parts. Why 5? I'm saying 5 splits. And each time only a set of 5 values will be part of test data set and remaining 20 will be
20 are training.
Okay. In training, there might be repetitions. Okay.
Correct.
But in test data set, there will be only once
Five. Only one.
will have a opportunity to become a test data set. Okay.
Okay.
If you see 5 iterations, 5 sets it has created. In the first set, some random 20
Random 20 values for training.
And 0, 1, 2, 3, 4 has become the test.
Yeah.
Okay. And this training data set will always be different from test data set.
Yeah.
Okay, because you don't see any of these test data set values here or any of these values here. Okay. Because it is just dividing.
Yeah.
Like that, 5 times it is doing randomly, and you can see these are the different values, different sets it has created. Okay. And these are its corresponding for each time. These are the corresponding test data set. But if you observe in trainings data set, there might be repetitions. For example, you see here 0, 1, 2, 3. There are many repetitions here.
Correct.
Okay. But in test data set, see from 0
yeah, everything is
4,
unique. Yeah.
is repeated only once. 0 came once only here. Not again. Okay. And 5, 10, 15. Not again.
Correct.
Okay. So that's just a basic example. Same thing will apply to our training, to our actual data set.
Okay.
Okay. Fine. So yeah. So over here, if you see, so from sklearn model selection, we are importing something called as cross-val score.
Okay.
Okay. So to perform, one thing is K-fold cross-validation. That is telling to divide the data set into how many folds. That is, we will use a K-fold cross-validation.
Yeah. Yeah.
Okay. But to perform the whole thing, like, for example, if K-fold equal to 3, okay, that means divide it into 3 parts and create 3 models. Model 1, model 2, model 3. Okay.
Correct.
And then generate, there will be one accuracy for this, accuracy for this, accuracy for this.
Correct.
And then a common average accuracy for overall. Okay.
Correct.
To do this overall thing, we will use just this cross-val score.
Okay.
Okay. So it is so simple. For example, if you see from sklearn model selection, I'm saying cross-val score. So here what I'm doing, you see each step. So first I'm starting an object, K neighbors classifier. I'm creating an object. As of now, I don't know which is the best K.
Correct.
So randomly I'm taking 5.
Okay.
Okay, fine. Now with this 5, okay, with this K equal to 5. So don't get confused between this K, that K.
Yeah, this K is for nearest one. Yeah.
Nearest neighbors, correct. So I'm saying 5, K equal to 5. 5 nearest neighbors I want. Okay. And I am doing a cross validation of 10.
Okay. So entire data will be divided into 10.
Yeah, correct. So that means what? The data set will be divided into 10 parts. And each time 9 parts will be considered as training and one part will be test.
Yeah.
And a model will be trained. Again, another 9 parts will be trained, one will be test, one more model will be trained. Like that, 10 models are trained.
10 models will be divided, yeah.
Okay. And 10 models, for example, this is model 1. Okay. Now, with this model, you will pass all your test data set.
But nearest is
pass your test data set. And then you will get the accuracy.
Yeah.
That will be this model's accuracy. Similar for M10.
Correct.
Okay. Accuracy. So this whole thing is happening in this when you say, this is my model, KNN. And this cross-val score is there, right? So in this cross-val score, I'm passing my model. Okay. And you need to pass your X and Y. And you need to tell what is the, how many folds you want.
Cross-validation folds, yeah.
Yes, CB, how many CB. This CB will internally do this operation.
Got it. Okay. Whatever you explained above.
A fold.
Yeah.
dividing and doing, right? So that automatically will be done when you just inside the CV. When you are saying
Okay.
cross score, inside that it will call the K4 cross validation and it will understand. So just you need to say, hey, I want 10 folds. So this will
Yeah.
divide the data into 10 folds and do everything. And model, it will use this model. And for all these 10 models, it is going to use number of neighbors equal to 5.
Correct. Each model only nearest
Same
is
model,
5.
yeah. So
Yeah.
in
Correct.
10 different models, the only
Hmm.
training data and test data will be different from each model. But
Correct.
nearest neighbors, the K is 5.
5.
Okay. So that is
Hmm.
what we are doing. And like that, 10 models are trained and then you will get the 10 accuracies.
Hmm. Hmm.
Okay.
Hmm.
Uh,
Got it.
yeah. So you are passing the X and Y. So yeah. So you are passing X, Y. So you got the accuracy. Okay. So
Yeah.
these are the scores. So that's why if you see, you are getting 10 scores.
Hmm.
Getting?
Yeah.
So when you're printing scores, so this is for the first model. This is
Yeah.
for the
Correct.
second model like that. Okay. For example, if you're getting, I'll go with 5, CV equal to
Hmm.
5. So I'll get
5
5
models.
scores.
5 models.
5 scores.
Yeah. 5
And
scores.
each score is using K equal to 5
Correct.
because neighbor 5.
That should be same for every model, right? Because then only we will get to know which one. I mean, which one we need to consider.
Huh. Yeah, you are right. Yeah. But when you are doing one cross validation,
Hmm.
if you're doing like 5 folds,
Hmm.
so 5 models are getting trained.
Correct.
So for every model, you will pass the same
Correct.
K nearest neighbor value.
Yeah. 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 Got it.
Correct? So
Yes.
because in one set you want to find out you want to give opportunity for every data point to become a test data set, right?
Correct. Correct.
K value is fixed, you will do this
Correct.
operation because
Yeah.
if you change both, then you cannot validate, right? So
Yeah.
because
Yeah. What is the use? Yeah.
what
Yeah.
is the
Yeah.
use?
Yeah.
Correct. So yeah. So but the idea is now we will see initially we will say with K equal to K nearest neighbor equal to 5, then we will do one set of the CV. Okay, then
Hmm.
we will go to K equal to 6.
Correct.
Keeping six as fixed, then again we will train like
Same CV equal to 5 again. It's only we will do K equal to 6.
correct. Okay. So for example, here if you see now when I do CV equal to 5, now I got C. This is
Hmm.
one first model accuracy, second model, third model, fourth model, fifth model.
Yeah.
Okay. I can change the n numbers equal to 9 also, 3 also. So this is
Yeah.
okay. So this
That
yeah. So this is just
that
a
CV equal to 5 is fixed basically.
it is
We will always change is nearest neighbors 3, 4, 5 to up to 30.
correct. Correct.
Yeah.
So but CV also
Mm-hmm.
see CV also is an hyperparameter. Right?
Correct.
Any
Okay.
number you see here, that is a
True. True.
hyperparameter. I don't know which is a
True.
so one thing is initial, but we will range between the values of this K and N, let's
Mm-hmm.
say from 3 to 30. Okay, but for CV, right? So CV, there is no rule that CV should be 5 or 7, but usually you can just try with one set, this overall set with 5
Mm-hmm.
and 7 or 3. Okay,
Okay.
you can try with like 3 to 4 values, and that should be good.
Okay.
That's
But I
CV.
have doubt.
Hmm.
When CV equal to, if you have given, let's say 5, so for K, here we got 5 scores, right? Okay. And for example, if nearest neighbors, we have taken 5. Okay. First, this is 3. Okay. But CV equal to 5 means we got 5 scores. The same
No,
next,
one second. This is the K value. This is the CV value.
correct.
Now tell me what K value you want?
Yeah. For example, now we got K, I mean, K equal to 3.
3, correct. And CV equal to 5.
5. 5 is fixed. Let's say 5 is fixed for everything. K equal to 3, 4, 5. Okay.
Okay. 5, yeah.
Okay.
Yeah, CV will fix.
Yeah.
You're correct.
So,
CV will fix.
yeah. Now
Let's
K
say
equal
5.
to
This is
3,
fixed.
K equal to 4, K equal to 5. But here, which scores we need to check for the best. How will we get to know? Because this is not one, right? This is 5. We are considering 5 scores. 5 should be ones or 5 should
Yeah,
be 0.
correct. 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 So if you see, these are
Mm-hmm.
the scores. In next step, we are doing the mean of scores.
Okay, sorry. Yeah, okay.
Okay.
Hmm.
So finally, for K equal to 3,
Yeah,
internally it is creating 5 models and you're getting 5 scores. But again, we will do the average and you will get only 1 score. That means finally,
yeah,
for
yeah.
every K, you will get only 1 score.
Okay, okay,
For
okay, got it.
4, there is 1 score, 5, 1 score. Then we'll take the best score.
Okay, okay, got it.
Clear?
Yeah.
Yeah. So as you can see, now I'm putting k equal to 3 and CV equal to 5. I got 5 scores. Okay,
Mm-hmm.
I'll run this again. Okay. And this is a mean of that score.
Yeah.
So that means this is a score of k equal to 3.
Yeah.
Getting?
Good.
Fine. Now see what I'm doing. So I am putting CV equal to 5 as fixed.
Mm-hmm.
Okay. And I'm ranging from 1 to 30.
Okay.
Okay. That means what? Now k value, initially k will be 1. Okay, now k
Huh.
equal to 1, I am training 5, CV equal to 5. I am training 5 models, each 1, 2, 3, 4, 5. With each model will work with the k equal to 1. That means it will consider only one nearest neighbor. Okay, like
Huh.
this will also work, this will also work, this will work. But why 5 models? Because each model test data set is different. So that's why 5
Correct.
models. Okay, and then after that you will pass the test data set and you will get the accuracy. So each of these will give you 5 accuracy. The mean of these 5 models will be one accuracy, that is called k equal to 1 accuracy.
Correct.
Clear?
Yeah.
Next k
So,
equal to 2.
hmm.
Now k equal to 2, again CV equal to 5. Here also we will divide the you will have 5 models. Okay. But now here each model will consider 2 nearest neighbors.
Correct.
Okay. So then it will have accuracy, accuracy, accuracy. Then the combined accuracy will be second accuracy, which is k equal to 2 accuracy. Like that till 30 you will do, where in the 30th here also you will have 5. The data is divided into 5 parts because CV equal to 5. But here you will consider 30 nearest neighbors. And finally, each of model will give you an prediction and accuracy you will get. So then an average of these 5 where k equal to 30 will be the 30th accuracy for the k equal to 30. So now you got 30 accuracies
Correct.
for 30 case.
Yeah.
You pick the one which with the maximum accuracy.
Got it.
Yeah. Now tell me your doubt.
No, no, no. It's clear.
Clear, right?
Yeah.
Okay. So there should not be any confusion here because
Hmm.
this could be slightly confusing between k values and k nearest neighbor and k fold, but I don't think it should be that difficult. Okay.
Yeah, it's fine.
Yeah.
Understood.
So now here, if you see, for example, I'm ranging from 1 to 30. Okay. And what
Hmm.
I'm saying, so I'm saving all my in each for each k, I'm saving my k scores.
Yeah.
Okay. And this is my k nearest neighbor classifier I'm doing. See, here is a k. So that means what? Every time I'm ranging from this list means first it will be 1, 2 like that. K
Yeah.
neighbors. And inside that I'm using the same cross validation part I'm using here. Okay. And I'm using CV equal to 5. That is fixed.
Hmm.
Right. So and then so what will happen? So here when you are having initially when k equal to initially when k first time the value of k will be 1. Okay,
Yeah.
so this k will be 1.
Correct.
So here inside that CV equal to 5. So every time, no, even if it is 1, 2, 3, every time we are training only 5 models.
Correct.
So you will get 5 scores.
Hmm.
Okay. So then you,
You're a
you,
mean.
you are doing the mean. So
Yeah.
finally it will become 1 score. So
Only one only. Yeah.
for 1k, 1 score.
Correct.
Correct? For like that, if you're looping till 30, you'll get 30 scores.
Yeah.
Clear?
Yeah. Even k equal to 2 also will
2
get
also,
only
yeah, 2
one
also,
one
so
mean.
we get
Yeah.
5 scores. For 2
Correct.
also 5 scores. And you are doing the mean. For 3 also 5 scores. Finally, you will
You'll
get
get
30
30.
scores. Okay.
Yeah.
So if I run this, for example, yeah. So you see this 0.96 is the
For
mean
k
score
equal to 1.
for k equal to 1. Correct. Okay.
Correct.
So now this overall k scores. So now if you see the length of this k scores, it is 29 because from 1 to 30, right? So it will consider only
Yeah.
1 to 29.
Yeah. Yeah.
Correct. So you're having 29. So, but for example, if you want to, I'll just go with 10. Okay.
Mm-hmm.
Only 10 times it is 10,
10 nearest
10
only.
till 10. Okay.
Hmm.
So here, how many scores
9.
I get? 9 scores I got. Okay.
9.
So
Yeah.
this is the for k equal to 1, k equal to 2, 3, 4, 5, 6, 7, 8, 9.
Correct.
Okay. But this score is coming from 5 models.
Correct.
So say
5
equal to 5.
models.
So if you
Yeah.
if I want to show you, so if I just run this, so I'll also show you. Okay. For example, uh, let me print this. Okay.
Hmm.
Uh, Not length of the scores. Let's print the scores only. Okay, I'll print length also, and I'll also print the scores also. Okay. So here, if you
Hmm.
see, and also let me print the k. It will be there.
Mean.
K also I'll print, and this also.
So we can print individual mean also after each. Yeah.
I'll say. Okay, now you see.
Hmm.
Initially, when k equal to 1,
Yeah.
okay, so I'm printing length of scores. There are 5 scores
5.
you're getting. Why?
Yeah.
Because CV equal to 5. And what
Correct.
are those scores? These are the scores. First model, second model, third model, fourth model, fifth model.
Yeah. Yeah.
Okay. And the mean of this is this.
Correct.
Okay. That's why finally it is showing you 0.96.
Correct.
Okay. For example, if you see the last one, it should be 0.973 here.
Mm-hmm.
Okay. Last one, since you're looping from 1 to 10, the last one will be 9. Okay. K equal to 9. Again, you will have 5 scores. These are those 5 scores. Okay. This is the
Yeah.
first model score. This is second model score, third model, fourth model, fifth model. And the mean of these 5 model score is this.
Yeah.
Okay. That's why it
That
is
is the ninth one. Yeah.
ninth one. Clear?
Yeah. Clear.
Fine. So now here you can change and experiment and do anything. So if you want to change this, if you increase this CV equal to, for example,
7.
8, 7 or
Yeah.
something.
Yeah.
Okay.
Yeah. What?
So
Yeah.
now see, you're for each time, for each K, it will create 8 scores.
Hmm.
And it's mean.
Yeah.
And also you will have
Totally 8 models. Yeah.
8. No. Inside each inside each K, you will create 8 models and give you 8 accuracies. Okay. But finally,
Yeah.
how many times I'm looping? 10 times.
10 times. So 9 times. Yeah.
You will have 9. This will be 9 because for
Yeah.
each and every K, you will get one value.
Yeah.
Clear?
Yeah. Clear.
Okay. So let me loop through, let's say 30. Okay. And then this is 5.
Hmm.
Okay. So this
29.
is the thing. Okay. Finally, I got, these are my overall scores.
Correct.
Okay. These are my overall score for each K.
Correct.
Okay. Now I cannot average this.
Correct.
This we should
From
not.
this we need to decide
From this, we
which
need to find out
K,
which K
which
is
K
giving the
should be
highest.
the, yeah.
Okay. So for that,
Hmm.
I'll just plot this. Okay. I'm just
Mhm.
plotting K range and K scores. That means
Okay.
I have range from 0 to, 1 to 30.
29. Yeah.
And for each value, there is K scores. What is K scores? I'm adding all scores into this list. Okay.
Yeah. Mean.
So yeah, mean. Okay. So if I just plot those, okay. So these are my values.
Mm-hmm.
Okay. Because at 0, there is 0.96. Okay. Uh, 0.96 like that.
Correct.
So for example, yeah. So 0.96, 0.496. Okay. You're seeing first initially it is 0.96, next it went to 0.94, again 96, so 0.94, like that. Okay.
Yeah.
So yeah, so if you want, you can loop through any number and you can change this also.
Mm.
For example, I will change to 30, 10. So then for
Mm-hmm.
each thing it will do that. I'm not printing. Okay.
Yeah.
But it will initially see for each and every K it is, and these are the values.
Correct.
Okay. And now if I plot this, you see this is the
Mm.
values. Okay.
Yeah.
And here if you see 0, 5 for 10, for 15, for 20. So here we want the highest accuracy. So you
Mm.
see this value like somewhere around 12,
Correct.
13 it is giving, and 20, K equal 20 also giving good accuracy. But again,
Mm.
K equal to 30, it is giving less accuracy.
Yeah.
So there is no rule as you keep on increasing K, you will get better accuracy. No,
Correct.
correct. But
Correct.
why? Because if you visualize, if you just try to visualize, so when K equal to 15, you will consider 15 neighbors. So then that might be perfect number of neighbors you can consider, right? But if you keep on increasing unnecessarily, you are considering other points,
Yeah. Yeah.
correct? So
Yeah. Those are not
whatever data
required
set,
also.
yeah, which is not required also because uh, if our class is 1, okay, if you consider K equal to 15, yeah, mostly it is considering majority of 15. But if you include more, unnecessarily 0 class values are coming into picture. Then
Correct.
your accuracy will decrease, correct?
Correct.
It
Correct.
is based upon your data set. So that's why, so there will be some shuffling. So he's
Yeah.
saying, so at K equal to 20, you are getting good accuracy.
Yeah. So
Okay.
that comes under underfitting, right? If we are increasing, keep on increasing K
Correct.
value.
Correct.
Yeah.
You are right. If you keep on increasing, you're not fitting. Okay. But if you go with the K equal to 0, it's overfitting.
Yeah.
Very low value, you are just overfitting. Okay. So now what we did, so if you see, first initially we started with some random value of k equal to 5 because we don't know what is the best value. Then we loop through values, okay, and then we find out k equal to 20 could be the best value.
Mm-hmm.
Okay. Now what we are going to do, now we are going to train, now the actual KNN model will be trained using k equal to 20.
Correct.
Correct. So that's what we'll do. So now what we'll do, because we know k equal to 20, so now we'll
Mm.
come here and we'll say k fold cross validation n neighbors equal to 20.
Mm-hmm.
Okay, and then again we'll do this CVV. Okay,
Mm-hmm.
but here we'll not looping because we already know k equal
Yeah,
to.
we just to identify the accuracy. I mean,
Correct.
mean.
So this is the final model which
Yeah.
we got. Okay, so this is a KNN model. Okay, so when you train, yeah, so when you're saying KNN equal to k neighbors of equal to n neighbors equal to 20, and you are printing this, now you got the model KNN. Okay, so this KNN, okay, this KNN will have the knowledge of the on the training data it is trained on, and how much what is the n value I should use.
Mm-hmm.
I mean the nearest neighbors k value basically.
Mm-hmm.
What is the k value I should use. Okay.
Yeah.
So now
Yeah.
you can deploy this model. Okay. You can deploy this model in some cloud. Okay. As
Mm-hmm.
we are doing. So now when a pass an input data set, so by default, it will consider 20 nearest neighbors.
Nearest neighbors.
Okay. On the
Yeah. Yeah. Yeah.
because it is trained on the training data set. Okay.
Correct.
And also you should pass the training data set also.
Hmm.
Okay. Because there is no training that is happening, right?
Yeah.
So it will consider the training data set, and based upon that, it will give you the this. I mean, while prediction you might need not pass, but while for while training, there is no actual training that is happening, right? So when you pass any point, it will use the whole training data set and it will give the prediction.
Yeah.
Right. So we got the 20, and I would say, yeah. So this is one thing, and here just to compare, I have just shown you if you use the logistic regression
Mm-hmm.
for the same data set. In logistic regression also you can use CVV. CV,
Okay.
these are general topics.
Okay.
Classification matrix, K-fold. Okay.
Mm-hmm.
Here also you can use. The idea is here also it will divide into 10 parts, and for every part.
Got it. Got it.
Okay. So here it is given 95, but you see
95.
this.
KNN, it is given 0.98. Yeah.
Okay. Fine. So I would say this is one way, basic example, and this way you can find out the value of K. Okay. It is using cross validation. Any doubts here?
No.
Okay. So that is regarding this part. And coming to one last point we had regarding the KNN is its hyperparameters. Okay. So every
Mm-hmm.
model will have, as I was showing, right? So here also, what is our model? My model is, for example, if I print my model, this is my model. Okay. See here.
KNN data model.
It's saying neighbors equal to 29. That means this KNN is a model that is trained where it will use k equal to 20, n equal to 29.
Yeah.
Okay, fine. So now when I do KNN dot, what are those get model params, right?
Get pumps.
And this is a function. Yeah. So these are the hyperparameters.
Hmm.
Okay. We did not pass this.
Yeah.
We did not pass any of this. So these are by default. Okay. So now we'll see what are these. So initially, we have something called as neighbors, weights, algorithm, leaf size, this, etc. Okay. So all of these are not important, but we'll see few of this. One thing is nearest neighbors, which you know. Okay.
Hmm.
By default, it will be 5. If you want,
5.
you will change and we'll do. After that, weights. Okay. Weights is yesterday I was saying you, right? So
Yeah. Yeah.
one is distance. So uniform is it will consider all points will be treated with equal weights. But
Mm-hmm.
yesterday I was showing you one example where it is close to the.
Orange one.
But if you consider the k equal to 3, its classification will be different. Okay. But it is very close to the other class. In that case, we should also give preference to the distance.
Mm-hmm.
Okay. So that's why when you use weights equal to distance,
Mm-hmm.
the parameter. Okay. So that means what? Here, if you see by default, the weights is uniform.
Yeah.
Okay, but if you don't want, here when you are giving here, right? So you can say weights equal to
Equal to distance.
distance. Okay. You can mention this way.
Got it.
Okay. So in that case, what happens? The weight points by the inverse of the distance. Okay, that means if it is the distance between, if our test point, if it is very near to some point, if the distance is low, it will give more
Hmm.
weightage. More
Hmm.
it will give.
Okay.
I want that only, right? For a far point, if the distance is more, then weightage will be less. That means I will not give more importance to this fellow. If I'm
Okay.
very near to some person, that means the distance is very, very low, then weightage will be more.
Yeah.
Okay. The close neighbors of a query point will have greater influence than neighbors which are far away.
Hmm.
Okay. So that is regarding uniform distance. And if you don't want this, if you want some other function where you want how the distance and importance should be given. If you want to give some user defined function, you can give that function and you should mention it as callable.
Okay.
Okay. Fine. So usually by default, it will be uniform.
Okay.
Fine. And after that, we have something called as algorithm. Okay. So
Mm-hmm.
algorithm is one hyperparameter. Okay. So you know what it does. Uh, Basically, it will take these values, either auto, ball tree, KD tree, or brute. Okay.
Mm-hmm.
So what does this means? I will tell you what is the use of this. So, for example, if you are having 10,000 data points,
Mm-hmm.
training data set. Now, when you're passing a test data set, so what it will do, it will calculate the distance between all the data points, and then it will find out the nearest 5 or 10 depending upon your K.
Yeah.
Correct? That is a basic thing. If it is 1 lakh data points, then how many distance it need to calculate? 1 lakh.
Correct.
If it is 1 crore, then obviously it should calculate 1 crore distances and then come up with the top 3 or 5 or how many K nearest neighbors. Agree?
Hmm.
Sometimes this is not very much feasible and not recommended because calculating so many distances could be heavy. Okay. So in that case, these are just tricks to find out those nearest neighbors. Okay. The nearest neighbors will be 5. If you are giving k equal to 5, okay, you will get 5 neighbors. Okay. But the
Yeah.
approach of finding this 5 will be different.
Correct.
Okay. A small techniques we'll use. Okay. One is the one which we do normally, like
Hmm.
going, which will to calculate the distance of each and every point. Okay.
Hmm.
That is called brute.
Yeah. Okay.
Brute force. Brute in English also, brute means like
Y-
nail,
Fast force.
basic,
Correct. Good.
basic one. Okay. The brute force. There is some other thing called as ball tree and also KD tree. Okay. So basically KD tree and ball tree, and there is something called as auto.
Mm-hmm.
Okay. So we'll see what is ball tree and KD tree. Okay. But you know what is brute is what we do by default. There is something called as auto. Okay. So auto
Mm-hmm.
is, if you are not sure which one to use, you can simply use auto. And by
Mm-hmm.
default also it will be auto. Because for
Yeah.
example, in our this thing, it is auto algorithm.
Auto only. Yeah.
Okay. That means what? Auto, when you say auto, the algorithm will automatically decide which type
Which is
item.
appropriate algorithm. Yeah.
Okay. That it will use. Now, but what is ball tree, KD tree? I'll just give you an example. So here, if you see, yeah. So brute is like any type of data you can use. Okay. It is slow because you need to calculate so many distances. Okay. But
Yeah.
it always works. Now, KD tree, usually it works when you have numeric data.
Okay.
Your
No
data
dimension
is
data.
numeric data.
Mm-hmm.
Okay. And dimensionality should be 20 and it should be fast, etc., etc. But what happens
Okay.
here, in KD tree, what it does is, I'll give you, for example, you are having data points like, 5 comma 4 and some 6 comma 8 and 3 comma 2 and let's say 1 comma 7. These are 4 data points. Okay.
Yeah.
Now, if given a new data points, let's say 2 comma 2,
Mm-hmm.
you need to calculate distance between all the data points.
Yeah.
Correct. But in KD tree, what it does is it will create a tree-like structure. Okay, that means
Mm-hmm.
initially it will start with one node. Okay, so a tree-like structure is in the way like this. Okay, like this. So how it will do means it's a very simple thing. So first it will start with some axis. Let's say it's a initial x-axis. So what are all x-axis values? 5, 6, 3, 1.
One.
Okay. So it will add all those 5 plus 5 plus 6 plus 3 plus 1. How much it
Mm.
is? 15.
11, 15.
15 by 4 average value.
Mm-hmm.
So it is
4 near
point
2.
something.
Mm.
Okay, 3.9. Okay. So which is very close to this. it will consider that value. So 3.9 is almost 4. Okay. And for 4, there are two values that are close. Okay. One is 5 and one is 3.
Yeah.
Okay. 3 or 5. So you can consider any value. So let's say I will take 5.
Mm-hmm.
Okay. So I will take this value, this data point. Okay. Here it is 5 and 4 will be here.
Okay. Okay.
Okay. Now, based upon this, it will divide into two parts the whole data set. That means what? I will say this is 5. So
Mm.
greater than 5, greater than or equal to 5 will be this side. That
Less than or equal to 5 will be
points.
right side.
And less than 5 will be this side.
Yeah.
So initially we are from here we'll create 2. Okay, forget about this. Okay, we are
Mm-hmm.
creating 2. So greater than 5 means what? 6 comma 8
6
and
and the item.
only 6 comma 8. Okay, so 6
Yeah.
comma 8 will come here. Okay,
Mm.
and less than 5 is 3 comma 2 and 1 comma 7. Okay, 3
Yeah.
1 7 will come here. Okay,
Mm-hmm.
so the importance of this is, for example, a new query comes here. So instead of initially, if it is brute force, you need to calculate for every distance.
Correct.
Now, if it is 2, you can check with the x-axis 2. Okay. So, and you can
With
see whether it is greater than 5 or less than 5. Okay. So, if it is less than 5, so you can start searching in this way.
I mean, half of the search will be already finished
Already,
based on, yeah.
eliminated.
Mm.
Agree? But
Yeah.
again, you have y-axis. So, from this, again, it will create, for example, here you have 2 points. So, here what it will do, again, it will take, let's say now it will switch the to other axis. So, 2 and 7. Okay.
Yeah. Yeah.
Y-axis 2 and 7. 2, 7, what is sum 9? Average is
Yeah.
4.5. Okay. So what it will do, something greater than 4.5 will be here. That means 1 comma 7 will be here. Less than 4.5 is 2. 3 comma 2 will be here.
Okay.
Correct? So again, there is division. So when you get, so like that, you can create, here we are having only 4 points. Let's say if you're having 1 lakh points, there will be large tree like structure. Okay. And when you have a new query point, based upon these conditions, you can, pass through the tree and you can minimize the number of computations you can make.
Yeah.
Getting?
Yeah. Yeah.
Getting right? Because here, because you are having only 2, you will just consider only 2 conditions. But usually, for example, you are having like 10 features. In your Titanic
Mm.
data set, you are having 10 features, right? All these are
Correct. Correct.
features. P class,
Correct.
gender, etc. So then what you will do, you'll have like 10 features. So first feature you will take and we'll see which side I should go.
Mm.
Based upon that, you will slowly find,
Correct.
you'll get a set of one structure you will get, and in that you can find out the nearest neighbors. Okay, so at
Yeah.
least your
Yeah.
job is becoming a bit easy.
Correct.
Okay, but it should be careful. There is no guarantee that it will always work. So that's why it is not good in very high dimensions. If you're having very high dimensions, it might be not that
Yeah.
good.
Yeah. Complex. Yeah.
Okay,
Correct.
yeah, but numeric data it works well.
Mm-hmm.
Okay, that is regarding KD. And ball tree, ball tree here will not do these things, but basically, I did not use ball tree, but the idea here is simple. The overall data, okay, you will divide into different, balls.
Mm-hmm.
Okay. So on maybe on some conditions or for numeric for KD tree, though you will use specific numeric conditions and divide. Okay. But if it is not numeric also, so in balls tree, it will divide into some clusters kind of thing.
Okay.
Okay. Maybe uh, if it is categorical, let's say gender, if it is gender, one cluster, if it is not some other cluster, something like that. Okay.
Okay.
So then you will go and find out in only in that cluster, the
Got
nearest.
it.
Okay. So I don't use that. So I'm also not very clear, but it is not a big thing. Okay. So if you're interested,
Okay.
you can just once try to Google. Okay. But the basic idea is it will divide it into different balls based upon some conditions, and it will work for not only numeric but other type of data also.
Okay.
So these are just techniques where you can minimize your computations and find out. Again, you will get 5. When you're saying k equal 5, you will get 5, but 5 you will get in a less amount of time.
Yeah. Yeah.
You will get a better nearest neighbors. Okay,
Hmm.
fine. And then auto. If you're not sure which one to use, just go by auto. It will only
Yeah.
based on the data set you will find out. Okay, that's why by default it will be auto only.
Got it.
Okay, so that is auto. Yeah. So and what do we have? This is algorithm and leaf size. Okay, so if you're using this leaf size, right? So these are leaves. Okay, so these are leaf size.
Mm-hmm.
No, I think the last one. So wherever you are having the last one, right? So these are leaves. I think these are nodes. Okay, the first one. So the ending parts are leaves. Okay,
Leaves. Yeah.
so how many leaves? Still, how much you want to divide?
Okay.
Okay, so what is the length of this tree? If you can control by saying by default 30, so 30 times it will divide. Okay, but if you want less, it's fine.
Okay.
Okay, because this, if you have a big size, okay, this will affect the construction as well as the memory size. Okay, because you need to store the complete tree, right?
Yes.
All those values. Okay, that's. And what is P? P is the, we have seen this, right? So
P
metric could
equal
be
to 2 by default. Yeah.
Minkowski, etc., etc. And metrics is nothing. Njobs is to use the all cores. Okay, related to hardware. Okay, yeah. So these are the basic hyperparameters which we had. Fine. And after that, these are the attributes. We have few attributes like, classes. Uh, from the model, what all we can get.
Mhm.
Once the model is trained, I'm now Canon is trained. Okay, now I use when I say this. What is this? Canon is this removed? Uh, in that case, I'll do just like this, and I'll say classes. Okay, then what it is renamed with? Looks like classes is removed. Not sure why.
Mhm. Yeah.
So effective, there might be some update. Effective metric, also not having. But we'll see from this one. Yeah. So this is algorithm I'm having and k neighbors. It is saying 29. Um, and some other attribute in neighbors it is 25, and this any other attribute. Oh, here also you have predict prover.
Yeah.
We have weights. Weights are uniform.
Mm.
Okay, so some attributes it is giving. Fine.
Yeah.
So best thing you can refer this documentation part. Okay, here I have few examples. Fine. So I would say that is regarding the KNN, Karthik, and this should be enough. For the starting stage. So
Yeah.
code part, I recommend you to once go through this. I'll share you this uh, cross validation part. So I have used yeah, I've used it from here. Okay.
Mm.
Uh, if I send it in the chat, can you get it? I think you will be able to get. Yeah, you can go through this very simple one, and you'll get the idea of cross validation. You can try giving different values of case and cross validation and see. Okay.
Yeah.
So let me know if you are able to access that, or else I can send you. Okay. But I would say, yeah. So I think we have covered a good amount of theory and regarding the k values discussion, and also the mainly the code part and the hyperparameters also. Okay.
Yeah.
Yeah, I think we are good with this. Any questions?
No, Santosh.
No, right? Okay.
Yeah.
Yeah, that's all for today. And as I said, the next class we are going to start the Navy base.
Okay.
Okay, Navy base. And the idea is to complete this one first. It might take like max 3 or minimum 2 classes. And
Okay.
after that, then we are going to start very interesting model called as tree-based models. Okay. Now,
Okay.
tree-based models are, the mostly used models in ML
Okay.
solutions. Okay. Here you have like 4 to 5 models, etc. We'll see those. Okay. Fine. That's all for today. Okay. Let's meet again. Bye.
Yeah. Bye. Thanks.